In this video, we can discuss about microbiological assay. Before starting the topic, let's have an idea about assay. What is assay? Assay are investigative procedure for qualitative assessing or quantitative measuring the presence or the amount or the functional activity of the target entity, which is known as analyte, and which can be a drug or a chemical substance or organic matter. So these are the procedure to determine the presence or to determine the quantity of a chemical substance in a sample. And this can be done by different methods like chemical assay, biological assay, microbial assay and bioassay. Now let's see what is biological assay. Biological assay is a biological testing procedure for estimating the concentration of a pharmaceutically active substance in a formulated product or bulk material. It is the measurement of relative potency of an activity of compound by determining amount required to produce the anticipated effect on a suitable test organism under the test. It differs from the chemical assay in the sense we will use in animal or any other biological models for the determining the effect of pharmaceutically active compounds. Now coming to microbiological assay. It is also known as microbial assay. It's a type of biological assay for the qualitative or quantitative determination of any chemical form of a simple or even complex material with use of a microorganism. So it differs from biological assay. Here we are using a microorganism for determining the effect of any drug. In microbial assay, evaluation is performed with the culture of microorganism and measurement represent the average response of extremely large population of the test organism. Usually a linear relationship between log dose and response is the characteristic of microbial assay. So this microbial assay is mainly used to determine the activity of newly discovered compounds or new drug discovery. And it differs from other chemical assay or biological assay. Only two kinds of drugs can be assayed by microbial assay. That is, either the drug should have an activity like antibiotic or activity like amino acids or vitamins. So activity of antibiotics can be standardized by the extent of the ability to inhibit the growth of microorganism. So the drug substance, either it should inhibit the growth of microorganism, or we can use the substance like vitamins or amino acid for standardization, which extend the ability to support the growth of microorganism. അപ്പോൾ മൈക്രോബിയൽ അസേ എന്ന് പറയുന്നത് നമുക്ക് രണ്ട് രീതിയിലുള്ള സബ്സ്റ്റൻസിനെ മാത്രമേ നമുക്ക് അസേ ചെയ്യാൻ പറ്റുള്ളൂ. ഒന്ന്, ഒരു ആന്റിബയോട്ടിക് ലൈക്ക് സബ്സ്റ്റൻസസ്, ഇറ്റ് മേ ഐദർ kill the microorganism, or like vitamins or amino acid which will promote the growth of microorganism. Now what are the advantages of microbial assay? The minimal requirement of space, labor and time, and it is useful for detecting change in the potency of physical and chemical assays. Now what is the disadvantages? Less reproducible and great error as compared to other assays. So these are the advantages and disadvantages of microbial assay. Now coming to microbiological assay of antibiotic, which is an important topic which is seen as an essay as well as short note question. Microbiological assay of antibiotic. So microbiological assay of antibiotic is based upon the comparison of inhibition of growth of microorganism by measured concentration of antibiotic to be examined with that produced by non-concentration of standard preparation of antibiotic having non-activity. So ഇവിടെ നമ്മൾ ചെയ്യുന്നത്, നമ്മൾ സ്റ്റാൻഡേർഡ് ആയിട്ടുള്ള കുറച്ച് ആന്റിബയോട്ടിക്കിന്റെ എഫക്റ്റ് നമുക്കറിയാം, അതുമായിട്ട് അൺനോൺ സാമ്പിൾ കമ്പയർ ചെയ്യുക എന്നുള്ളതാണ് ബേസിക് ആയിട്ടുള്ള മൈക്രോബിയൽ അസേ ഓഫ് ആന്റിബയോട്ടിക്കിന്റെ പ്രിൻസിപ്പിൾ എന്ന് പറയുന്നത്. Now, what are the different official methods for microbial assay of antibiotic? We have two official methods, method A and method B. Method A is cylinder plate or cup plate method, and method B is turbidimetric or tube assay method. Now let's see what is the principle of each method. First one, cylinder plate method or cup plate method or method A. The principle is depend on the diffusion of antibiotic from a vertical cylinder through a solidified agar layer in a petri dish or plate to an extent such that the kill the bacteria of a particular distance. This area is called zone of inhibition, and the concentration can be correlated with the zone of area of the zone of inhibition. അപ്പോൾ ഡിഫ്യൂഷൻ മെത്തേഡിൽ അല്ലെങ്കിൽ സിലിണ്ടർ പ്ലേറ്റ് മെത്തേഡിൽ ഒരു സോളിഡ് ആയിട്ടുള്ള അഗാർ ലെയറിലൂടെ എത്രത്തോളം ഡിസ്റ്റൻസിൽ ആന്റിമൈക്രോബിയൽ സബ്സ്റ്റൻസിനെ ഡിഫ്യൂസ് ചെയ്യാൻ പറ്റും എന്നുള്ളതാണ് നമ്മൾ ഇവാലുവേറ്റ് ചെയ്യുന്നത്. ആൻഡ് ദ ഏരിയ വിച്ച് ഈസ് inhibited can be correlated with the concentration. As the concentration increases, the area also will get increased. Now coming to second method, the turbidimetric or tube assay or method B. It is depend on the inhibition of growth of microbial cell in liquid culture. If the antibiotic kills the microorganism, turbidity of culture media reduces, and this can be observed spectrophotometrically by measuring the absorbance of the light. The absorbance can correlate with the concentration determination of unknown sample. So as we all know, as the concentration of a disinfectant increase in a liquid culture, it will decrease the turbidity by killing the microorganism, and this turbidity can be measured by spectrophotometrically. So we can correlate the concentration with the absorbance, which are determined by spectrophotometric method. So that is the principle of turbidimetric method. Now coming to the requirement of microbial assay of antibiotics. What are the things we have to prepare before performing the microbial assay? First, we have to prepare a culture media. Then we have to prepare a standard stock solution of non-compound and sample test solution to be whose activity to be determined. Then buffer solution, test organism and inoculum for the respective standard antibiotic substances and different apparatus. These are the requirements for microbial assay of antibiotics. First one, preparation of culture media. There are 10 official culture media which is prescribed in different pharmacopoeias. A to J, A, B, media A, media B, C, D, E, F, G, H, I, J. And how can we prepare the culture media? By dissolving the ingredient in sufficient water to produce 1000 ml. Then add sufficient 1 molar sodium hydroxide or 1 molar hydrochloride acid as required to maintain the pH between 6.5 to 7.5. We can modify some individual ingredient or we can reconstitute dehydrated media to provide the resulting media have an equal or better growth promoting property, or which should give the similar standard curve response. So these are the different official culture media which are specified in the different pharmacopoeias. There are 10 culture media A, B, C, D, E, F, G, H, I, J, and these are the gram per 1000 ml required of each ingredient. For example, culture media A consists of 6 gram of peptone, 3 gram of yeast extract, 1.5 gram of beef extract, pancreatic digest soya meal of 4 gram and 1 gram of dextrose and 15 gram of agar, and which is made into 1000 ml by using water. And finally, after the sterilization, pH is adjusted to 6.5 to 6.6 by using 1 molar hydrochloric acid or by using 1 molar sodium hydroxide. So that is the culture media which is used for the microbial assay of antibiotic. Now coming to the preparation of standard solution, and this is prepared by dissolving the quantity of standard preparation of a given antibiotic, accurately weighed, previously dried in a solvent specified, and then diluted to required concentration as indicated. And after the preparation, we have to store it in a refrigerator, and we have to use within a period indicated. So these are the different standard antibiotics and the standard preparation to be taken for preparation of standard solution, and this is the mg containing 1 unit. So for example, ampicillin, we have to take the standard preparation as ampicillin itself with a unit, international unit, which consists 1 unit of 1 unit is equal to 0.001764 milligram of ampicillin. Now erythromycin is dihydrate with international unit, 1 unit which is equal to 0.001053 milligram of erythromycin dihydrate. So this is the standard preparation. The authentic sample of appropriate antibiotic potency is previously determined by reference to international unit is taken for the preparation of standard solution preparation. Now coming to the samples, and we have to use the suitable solvent. For example, the streptomycin, we have to use water for the dilution, and the final stock concentration per ml should be 1 mg per ml, and it have to be used before 4 days. And for the preparation of test solution, we have to use water, and the medium dose per unit ml is 1 microgram, and we have to incubate this sample solution whenever required for performing the antimicrobial activity, microbial assay, at 30 to 35 degrees Celsius. So from the information available for the substance under the examination for the preparation of test solution or sample solution, assigned to it assumed to be potency under the unit weight or volume, and this assumption prepare the stock solution and the test solution as specified for each antibiotic on the day of assay. Well, we have to prepare the stock solution, and we can store for 14 to depends on the antibiotic, we can store for 14 to 4 days or etc. But the stock solution, from the stock solution, the sample solution or test solution should be prepared on the day of assay. That is the important thing. Now coming to the preparation of buffer solution. Buffer solution are prepared by dissolving specified quantities of dipotassium hydrogen phosphate and potassium dihydrogen phosphate in sufficient water to produce 1000 ml, and after that we have to adjust the pH with 8 molar phosphoric acid or 10 molar potassium hydroxide as required. So these are the different buffers with pH. For the preparation of buffer with 6 pH, we have to use 2 gram of dipotassium hydrogen phosphate and 8 gram of potassium hydrogen phosphate. And for preparation of 8 pH buffer, we have to use 16.73 gram of potassium hydrogen phosphate and 0.532 gram of potassium dihydrogen phosphate. So that is the preparation of buffer solution for the microbial assay of antibiotic. Now coming to the preparation of test organism and inoculum. The test organism for each antibiotic and method of preparation of microbial substance as prescribed as in pharmacopoeia. Volume of microbial suspension that produce the optimum response is determined usually experimentally. So these are some examples of antibiotic, its test organism which is prescribed in the pharmacopoeia, and the method of preparation we are performing with method A or method B, and the different media used for each antibiotics and incubation temperature and incubation time. So for example, ampicillin, we have to use the standard solution as ampicillin itself, and we will use the Micrococcus luteus as the test organism, and the method A, that is the disk diffusion method, will be used for the performance of microbial assay, and we have to prepare medium D for the performance of microbial assay of ampicillin, and we can incubate at 30 to 35 degrees Celsius for 24 hours for the to get the result of microbial assay of ampicillin. So other examples are rifampicin, Bacillus subtilis, by using method A, that is disk diffusion or couplate method, and by preparing media B 30 to 35 degrees Celsius for 120 hours. So that is the preparation of test organism and inoculum. So how will we prepare the test organism or inoculum? First, we have to maintain the test organism on a slant of medium A and transfer a fresh, and this is transferred to a fresh slant once in a week. Then we have to incubate the slant at a specified temperature for 24 hours using 3 ml saline solution. Wash the microorganism from the agar slant onto a large agar surface, and then further we can subculture this one for our microbial assay procedure. Now, what are the apparatus which are used for the microbial assay? For cylinder plate method, we can use petri dish, which is made up of glass or plastic, or rectangular glass tray also can be used. And for turbidimetric method, we have to use glass or plastic tube with uniform length and diameter and thickness, and the cylinder should be made from glass, porcelain or aluminum or stainless steel, and should have outside diameter 6 mm and length of 10 mm. All the equipment must be thoroughly cleaned and sterilized by dry heat or steam sterilization before and after each use. So that is the apparatus which are used for the microbial assay. Now coming to the methods which are used for the performing microbial assay. First one is method A, that is cylinder plate or cup plate method. The principle, as we mentioned before, it is depend on the diffusion of an antibiotic from a vertical cylinder or cavity or disc through a solid agar layer of petri dish or plate to an extent such that the growth of added microorganism is prevented entirely in the circular area or zone around the cylinder cavity containing solutions of antibiotics. And this area of clear area is known as zone of inhibition, and the concentration can correlate with the area of zone of inhibition, and thereby we can determine the unknown concentration of sample. Now, what is the procedure for cup plate or cylinder plate method? First, we have to prepare the suspension or culture media of the test organism for the respective antibiotic. ഇപ്പോൾ ഓരോ ആൻറ്റിബയോട്ടിക്കിനും ഓരോ കൾച്ചർ മീഡിയ നമ്മൾ ഒഫീഷ്യലായിട്ട് പറഞ്ഞിട്ടുണ്ട്. കൾച്ചർ മൈക്രോ ഓർഗാനിസം നമ്മൾ പറഞ്ഞിട്ടുണ്ട്. അപ്പോൾ കൾച്ചർ മീഡിയയിൽ ആ ഒഫീഷ്യലായിട്ടുള്ള കൾച്ചർ മീഡിയ കൾച്ചർ ചെയ്യുക എന്നുള്ളതാണ്. ഓക്കെ, ദെൻ we have to inoculate this prepared suspension or culture media into an liquefied solid assay media. ഓരോ ആൻറ്റിബയോട്ടിക്കിനും ഓരോ മൈക്രോ ഓർഗാനിസം പറഞ്ഞിട്ടുണ്ട്. ആ ഓരോ മൈക്രോ ഓർഗാനിസത്തിനും ഒരു കൾച്ചർ മീഡിയയും പറഞ്ഞിട്ടുണ്ട്. ആ കൾച്ചർ മീഡിയ ലിക്വിഫൈ ചെയ്തിട്ടുള്ള സോളിഡ് ആയിട്ടുള്ള കൾച്ചർ മീഡിയ 40 ഡിഗ്രി സെൽഷ്യസിൻ്റെ അടുത്ത് വെക്കുന്ന സമയത്ത് അത് ലിക്വിഫൈ ചെയ്തിട്ടാണ് നിൽക്കുക. അതിലോട്ട് നമ്മൾ നേരത്തെ പ്രിപ്പയർ ചെയ്തിട്ടുള്ള സസ്പെൻഷൻ ഓഫ് കൾച്ചർ ഓഫ് മൈക്രോ ഓർഗാനിസം ഇനോക്കുലേറ്റ് ചെയ്യുക എന്നുള്ളത്. Then after mixing this solid assay media with the suspension of culture media, this mixture is poured into an empty petri dish plate to give uniform solid depth to 3 to 4 mm. എംറ്റി ആയിട്ടുള്ള ഒരു പെട്രി ഡിഷിലോട്ട് പോർ ചെയ്യുക. 3 to 4 mm സൈസ് കിട്ടുന്ന രീതിയിലുള്ള ഒരു സോളിഡ് കൾച്ചർ മീഡിയ കിട്ടുന്ന രീതിയിൽ നമ്മളതിന് പോർ ചെയ്യുക. ദെൻ place a uniformly sized sterile metal cylinder, or we can make a bore or hole on the cavity of the solid media. അത് സോൾഡിഫൈ ആയതിനു ശേഷം അതിൻ്റെ മുകളിൽ ഒന്നില്ലെങ്കിൽ ഒരു മെറ്റാലിക് സിലിണ്ടർ, അതിലാണ് നമ്മൾ സസ്പെൻഷൻ ഓഫ് ടെസ്റ്റ് സൊല്യൂഷൻ, സ്റ്റാൻഡേർഡ് സൊല്യൂഷനൊക്കെ പോർ ചെയ്യാൻ പോകുന്നത്. അപ്പോൾ ഒന്നില്ലെങ്കിൽ ഒരു മെറ്റാലിക് സിലിണ്ടർ യൂസ് ചെയ്യാം, അതല്ലെങ്കിൽ നമുക്കത് ആ സോളിഡ് ആയിട്ടുള്ള കൾച്ചർ മീഡിയൻ്റെ മുകളിൽ ഒരു ഹോൾ ഉണ്ടാക്കാൻ വേണ്ടിയിട്ട് അതിനുള്ള ബോർസുകളുണ്ട്. ആ ബോർസുകൾ യൂസ് ചെയ്തിട്ട് നമുക്കതിൽ ബോർസുകൾ ഉണ്ടാക്കാം. ആൻഡ് add equal volume of standard test solution as well as standard solution to fill the cavities which are prepared on the solid culture media. Then we have to leave the plate for 1 to 4 hours at room temperature or at 4 degrees Celsius. Then after 4 hours we will have to transfer this into an incubator for a specified time at a specified temperature. Usually it is 18 to 24 hours at 30 to 37 degrees Celsius. After that specified time, we have to accurately measure the diameter or area of circular inhibition zone, and then from that we can calculate the result by using equation or by graphical method. So this is the detailed procedure. First we have to inoculate a previously liquefied media with appropriate request quantity of suspension of microorganism. Then add the suspension to the culture media at temperature between 40 to 50 degrees Celsius. Immediately pour the inoculated media into the petri dish or a rectangular plate to give depth to 3 to 4 millimeter. Then ensure that the layer of media are uniform in thickness by placing the dish at a level surface. യൂണിഫോം ആയിട്ട് എൻ്റയർ സർഫസും ഒരേ ലെങ്ത് കിട്ടാൻ വേണ്ടിയിട്ട് ഒരു യൂണിഫോം സർഫസിൽ വെച്ചിട്ട് മാത്രമാണ് ഈ ഒരു മെത്തേഡ് നമുക്ക് പെർഫോം ചെയ്യാൻ പറ്റുള്ളൂ. Now using appropriate buffer solution, prepare the solution of known concentration as well as unknown concentration by diluting the stock solution. Apply the solution to the surface of the solid media in sterile metal cylinder or cavities which prepared or by using a paper disc antibiotic in the agar plate. And the volume of solution added to each cylinder or cavity must be uniform and sufficient and almost to fill the hole which is then used. So this is the metal cylinder which is placed on the solid culture media. ഒന്നില്ലെങ്കിൽ ഇതിൽ നമുക്ക് pour ചെയ്യാം, അല്ലെങ്കിൽ ഇതുപോലെ സോളിഡ് കൾച്ചർ മീഡിയൻ്റെ മുകളിൽ ബോർസുകൾ ഉണ്ടാക്കിയിട്ട് അതിൽ നമുക്ക് pour ചെയ്യാം. അതും അല്ലെങ്കിൽ നമുക്ക് പേപ്പർ ഡിസ്കുകൾ യൂസ് ചെയ്തിട്ട് അത് വെച്ച് നമുക്ക് അതിനെ ഡിറ്റർമൈൻ ചെയ്യാൻ പറ്റും. ഓക്കെ, നൗ after we have to leave this plate after pouring the standard as well as test solution. We have to leave this dish for 1 to 4 hours at room temperature or 4 degrees Celsius for pre-incubation. After that, after 4 hours, we have to transfer this into incubator and we have to incubate at 30 to 37 degrees Celsius for 18 to 24 hours. After that, accurately measure the diameter of area of circular area. So this is the procedure. First we have to make an hole on the solid culture media. Then we can pour by using micropipette or by simply placing the non-concentrated paper disc on the solid surface. So after the incubation we will get a zone of inhibition like this one. So we can measure that zone of diameter of zone of inhibition. So after measuring the diameter of zone of inhibition, we can interpret the result of microbial assay by using this equation. L is equal to 3a plus 2b plus c minus e by 5. H is equal to 3e plus 2d plus c minus a by 5, where L is the calculated zone diameter of the lowest concentration of the standard curve response line, and H is the calculated zone diameter of highest concentration of standard curve response line, and C is the average zone diameter of 36 reading of reference point standard solution, and E, B, D, E are the corrected average value of other standard solution lowest to highest concentration respectively. Or we can use the graphical method to determine the unknown concentration. So by measuring the different zone of inhibition of standard concentrations, we can plot a graph with the log concentration on x-axis and diameter of zone of inhibition on y-axis. So we will get different diameter of zone of inhibition for the respective log concentration. So we will get 1 point here, 1 point here, 1 point here, so that we can plot a straight line with a positive slope. Okay, so from this slope, from this graph, we can determine the concentration of unknown sample by extrapolation method. So we can measure the zone of inhibition of diameter of zone of inhibition of unknown sample. So from this we can draw a line to this standard curve. So from this standard curve we can determine the log concentration of unknown sample by extrapolating to the x-axis, which will give the log concentration value of unknown sample. So by taking anti-logarithm of the log concentration, we will get the unknown concentration of test solution. So that is the method for interpretation of cylinder plate method or cup plate method. Now coming to next method, that is the turbidimetric method or tube assay method, that is the method B. As we mentioned, the principle, it is that depends on principle is depend on the inhibition of growth of microbial in a liquid culture media. If an antibiotic is there, it will kill the microorganism. The turbidity of the culture media will reduce, and this can be observed spectrophotometrically by measuring the absorbance of the light. And absorbance can be correlated with the concentration for the determination of unknown antibiotic sample. So what are the advantages of turbidimetric or tube assay method when compared with the cylinder plate method? Advantage is short incubation period. We can get the result within 3 to 4 hours. And disadvantage is presence of solvent residue or other inhibitory substance affect this assay more than the cylinder plate method, and this can be used for the cloudy or turbid preparations. Now coming to the procedure for turbidimetric method, first we have to prepare 5 different concentration of standard solution by diluting the stock solution, and we have to select the median concentration, and we have to dilute the solution of substance being examined to obtain approximately to this concentration as that of the standard solution. Then we have to place 1 ml of each concentration from this 5 as well as the unknown sample to an standard solution to each tube in duplicate in 2 number, and to each tube we have to add 9 ml of nutrient media with previously seeded with appropriate test organism. Then after that we have to place in an incubator or water bath which is maintained at 37 degrees Celsius for 3 hours. After incubation we have to add 0.5 ml of dilute formaldehyde solution to each tube, and then we have to measure the growth of test organism by determining the absorbance at about 530 nanometer of each solution in the tube against the blank in which we didn't add any 0.5 normal solution. So that is the turbidimetric method. ഇവിടെ 5 സ്റ്റാൻഡേർഡ് സൊല്യൂഷൻസ് ആദ്യം പ്രിപ്പയർ ചെയ്യണം. അതിൻ്റെ മീഡിയൻ എടുത്തിട്ട് ഇതിൻ്റെ ഇൻ ബിറ്റ്വീൻ ഏറ്റവും സെൻറ്ററിലുള്ള ഒരു കോൺസെൻട്രേഷന് ഈക്വൽ ആയിട്ടുള്ള ഒരു അൺനോൺ കോൺസെൻട്രേഷൻ്റെ ഡയലൂഷൻ ഉണ്ടാക്കണം. ഇതിലെല്ലാ ട്യൂബിൽ നിന്നും ഓരോ ml വീതം പുതിയൊരു ട്യൂബിലോട്ട് ട്രാൻസ്ഫർ ചെയ്യുക. ഓരോ കോൺസെൻട്രേഷനും ഡ്യൂപ്ലിക്കേറ്റ് ചെയ്യണം. ഡ്യൂപ്ലിക്കേറ്റ് മീൻസ് ഓരോ 1 mg/ml 2 mg/ml ഉണ്ടെന്ന് വിചാരിക്കുക. 1 mg/ml-ന്റെ 2 ട്യൂബ് ഉണ്ടാക്കണം. ഓക്കെ, സോ ഹിയർ 5 ട്യൂബ് ഉണ്ടെന്നുണ്ടെങ്കിൽ ഓരോ 5 കോൺസെൻട്രേഷനും ട്യൂബ് ടോട്ടൽ 10 ട്യൂബ്സ് വിൽ ബി ദർ. ആൻഡ് here we have to take the medium concentration of the 5 concentration. Then after that we have to add 9 ml of nutrient medium to each 1 ml. Then we have to incubate at water bath or incubator at 37 degrees Celsius for 3 to 4 hours. Then add 0.5 ml of dilute formaldehyde after the incubation. Then we will measure the absorbance at 530 nanometer by using spectrophotometer. So this is the procedure for that we have mentioned already. Now we can determine the result of turbidimetric or tube assay method by using equation the same as that we had mentioned, but the term is changed to the absorbance value. Okay, there it was zone of inhibition, here it will be absorbance. So L is equal to 3A plus 2B plus C minus E by 5, H is equal to 3E plus 2D plus C minus A by 5, where L is the calculated absorbance of the lowest concentration of the standard response line, and H is the calculated absorbance of the highest concentration of the standard response line, and A, C, B, D, E is the average response value of each concentration of standard response line, lowest to the highest respectively. And also we can determine the unknown concentration by graphically by extrapolation method, but the term is here we will plot a log concentration versus mean absorbance value, and we will get a negative slope. Why? Because as the concentration increases, the absorbance will decreases. നമ്മൾ ആൻറ്റിബയോട്ടിക്കിൻ്റെ കോൺസെൻട്രേഷൻ കൂട്ടുന്നതിനനുസരിച്ച് മൈക്രോ ഓർഗാനിസം കൂടുതൽ കില്ലാവും, അപ്പോൾ കൂടുതൽ ക്ലിയർ ആയിട്ട് വരും അപ്പോൾ അബ്സോർബൻസ് കുറഞ്ഞു വരികയായിരിക്കും ചെയ്യുക കോൺസെൻട്രേഷൻ കൂടുന്നതിനനുസരിച്ച്. അപ്പോൾ നമുക്കൊരു നെഗറ്റീവ് സ്ലോപ്പ് ആയിരിക്കും കിട്ടുക. ആ സ്ലോപ്പിൽ നിന്ന് നമുക്ക് അൺനോൺ സൊല്യൂഷൻ്റെ അബ്സോർബൻസ് നമുക്ക് മെഷർ ചെയ്തെടുത്ത് അതിൽ നിന്ന് നമ്മൾ എക്സ് ആക്സിസിന് പാരലൽ ആയിട്ട് നമ്മൾ ലൈൻ ഡ്രോ ചെയ്യുന്ന സമയത്ത് നമുക്ക് ഒരു പോയിന്റിൽ സ്റ്റാൻഡേർഡ് കർവുമായിട്ട് മീറ്റ് ചെയ്യും. അവിടെ നിന്ന് അത് നമ്മൾ എക്സ് ആക്സിസിലോട്ട് എക്സ്ട്രാപൊളേറ്റ് ചെയ്യുന്ന സമയത്ത് നമുക്കൊരു ലോഗ് കോൺസെൻട്രേഷൻ വാല്യൂ കിട്ടും. ദാറ്റ് ഈസ് ദ ലോഗ് കോൺസെൻട്രേഷൻ വാല്യൂ ഓഫ് അൺനോൺ സാമ്പിൾ. ഫ്രം ദിസ് വി ക്യാൻ ഡിറ്റർമൈൻ ദ ആൻറ്റിലോഗരിതം. By using anti-logarithm of log concentration value, we can determine the unknown concentration of the test solution. So that is all about the antimicrobial assay of antibiotic. It's an important topic in the pharmaceutical microbiology, which is usually seen as essay question as well as short answer question of antibiotic. So in this we have to write the what is the standard solution and what is the standard drug we have to take, how will we prepare the standard solution, how will we prepare the stock solution, how will we prepare the buffer solution, and how will we prepare the microorganism, or what are the respective microorganism for respective antimicrobial agents or antibiotics, and the two official method, that is turbidimetric as well as couplet method A and method B, that we have to write in detail. So hope it is clear. Thank you for watching this video.